Okay, good afternoon again. I guess no other questions, and I'm going to open the lab manual so I can start sharing with you. I'm going to just share the lab manual with you so we can answer your question based on the lab manual for this experiment. Okay. So again, the part that we were worried about, polarimeter, of course, I don't have access to polarimeter from home, and I'm just gonna leave that to you, your responsibility to pay close attention to the video and watch the video for how it's working. So we went over this introduction, the separation of the enantiomers using resolution. And with the resolution, just make sure that everything is on here. First, we are going to mix the pair of enantiomers with tartaric acid. Then we get the crystals. Okay. We get the mixture of the two diastereomers. One of these is going to be this one is going to be in prismatic shape crystals. The other one at this point is in the solution. So when we do the filtration today, when we filter it, we only end up with this compound, with this one, the crystals. And we place that in a boiling flask. We add sodium hydroxide. Sodium hydroxide is going to cleave off the tartaric acid. Tartaric acid is highly soluble. It would show up in the aqueous solution, but the amine is going to form that ring, the oily ring, which is the second layer, and that is the product that we are looking for. So NaOH is the reagent in this case, is going to cleave off the tartaric acid. And when the tartaric acid is cleaved off, then you are going to use distillation to distill. It's basically steam distillation. It's basically the steam distillation, but we are not setting up with the 3-neck flask because we don't want to add water later on. So it's just one-time steam distillation. So when you are distilling, steam and the oil, which is the amine, is going to go to condenser and is going to condense. And when it does condense, then you are going to use extraction. So this experiment, you're experiencing resolution with the distillation and extraction combined. After you have it in a separatory funnel, when you separate them, before you separate them, you are adding NaCl. NaCl lowers the solubility of the oil in water. So it would basically remove all the water, excess of water from the organic layer, which is a good thing. And then you are going to drain it. There would be some moisture still left, and that's why you are using carbonate. Yes, that's what the salting out of the amine means. And then you are going to use the carbonate as the anhydrous agent. We go to the procedure. Okay. Let me see. I have to. Okay, so after you have it in the separator funnel, because we did up to step 7 last time. So on a step 8, it says repeat if we don't have crystals, but with the 2 weeks we do have crystals. And when you vacuum filter it, you are adding cold methanol just because you don't want to dissolve. So cold methanol, the fact that you're trying to wash it, but you don't want to dissolve your crystals again. Then when you have the 2 phases, you're adding the sodium chloride to salt out the amine, so you get the amine separated from the aqueous layer. And then to dry the organic layer after you separate it, because these are the techniques that you have used already. You are using anhydrous potassium carbonate. We don't use too much to kind of soak everything, but we have to get enough to remove all the water, so you get like clear solution. Then we are going to remove the organic layer, measure the mass. Why do we need to measure the mass? And I have to go back to polarimeter and the formula that we are using to calculate a specific rotation. We measure the mass, then we are going to mix with methanol and run it, the test for rotation, the observed rotation. So the rotation, the alpha, it depends on concentration of the compound. First of all, your compound must be chiral. When you are mixing with methanol, you're not damaging it because methanol is not chiral. So only any rotation is going to come just from the compound. But the rotation depends on the concentration. The higher the concentration, the higher the rotation is going to be. And also, it depends on the length of the cell that is used. Is it 2 decimeter or 1 decimeter? Those are the 2 standard length for it. So either is 1 decimeter or 2 decimeter. So we are using the 1 decimeter. So that's why we are dividing by 1, or we are using the length as 1. And when we have the specific rotation, so we can calculate a specific rotation. So we have to count these into the factor. These are the factors that can affect the specific rotation. The observed rotation depends on the concentration. It depends on the length. Concentration is gram per milliliter. So how much methanol you're adding, that would be the milliliter used for the calculation of the C. So if we are adding 7.5 milliliter, we use that as a 7.5. So gram divided by 7.5, that gives you the value for C. So we have the values here. You get the specific rotation. A specific rotation is going to be 40.3 if your enantiomer that you separated was 100% pure. If that value is less than 40.7 or 40.3 after you do the calculation, that means that you have some degree of purity or optical purity, but it's not 100% purity. And you want to find out what is the optical purity. In order to find the optical purity, the number that you find from the calculation to find a specific rotation for this experiment, you divide that by 40.3, and 40.3 is the reported number in this ebook for the pure sample of your amine. And that's what you are using. And to be consistent, everyone should use this, because I had a question earlier in the week that another reference book used a different number. So we are using this value, 40.3, to be consistent. And you find the optical purity or enantiomeric excess, which is the same calculation for it. And then if you want to find percent for each, you are going to use this example here to find the percent for each. Let me go back to the other room to look at the chat. I'm sure there was a question because I heard a click. What is the 169? Where did you find the 169? Oh, 169, I'm sorry. I see it on the equation. in the equation, this 169, if you add these two up, your y would cancel. Okay, x plus y is 100, x minus y is a 69, and 69 is the percent purity. So when you, it's like a two equation with the two unknown. So you cancel these two y's, and then 2x is 169. So you're basically adding these two equations together in order to find the value for x. And if you have the value for x, you can use either one of the top equation in order to find the value of y. Okay, perfect. For the polarimeter, when you are looking through the polarimeter, you have like you have two filters for the light. One is in this area, and then the other one is here. Then you have this movable plate that can measure, but what degree. If your sample is not chiral, you will see this shade of the light. Both half circle is going to be same. And if your sample is a left rotatory, the left side would be dark. If the sample is a right rotatory, the right side is going to be darker after you place the sample. So if you place a sample that is not chiral, you should see the center image. If the sample that you place in the cell and you place in the polarimeter is a left rotatory, then you would see the left image here, which means that is going to be left side would be dark. So what you do, you are going to move this plate. There's a handle that you can move, use it, and you are going to rotate it to the left side until you see same shade again. And when you see the same shade again, you are going to see this degree of the rotation on the plate. That is your observed rotation. So if the filters are parallel to each other, the only way that you can see the light if they are aligned, or if the light has changed direction, you have to move the filter to make it align again for this light in order to view it. How many degrees does it take for you to see the light again? That is known as the alpha, or the observed rotation. When you have that number, you have the mass for product, you have the volume for methanol, then you can do your calculation and write your lab report. Okay, if you have any question, I could answer your questions. If you don't have questions, then I would move if you have any concerns. And then I call the attendance, and then we're done. Just do 100 minus optical purity and divide the remainder of the two to get the percent. Maybe you can. If that is a shortcut, that's perfect. 100 minus that. Let's see if it works. Maybe it does work. Sometimes you guys can come up with shortcuts that it helps you and everybody else. Let's see. What would be, yes, exactly. 100 minus the percent purity, and then you said divide by 2. And then divide remainder of the 2, divide the remainder by 2 to get the percent of each. Okay. Okay, that's good. So basically, this one is showing the equation. Then what you learn there is going to make what you learn here on the equation. It actually makes sense because it's a math problem in the science problem. There's no single way. As long as your final answer becomes the same, it's going to be valid. So there is no single way. The same way that you have like optical purity, you have enantiomeric excess, same thing, different saying. So there is no whichever way you feel more comfortable, you use that. Both of them are valid. Very good. But this the formula that we have on that page 88, it actually shows the facts, right? the total of the two enantiomer is 100%. And then when you say the optical purity or excess of enantiomer is the difference between the two. So basically is expressing the fact and what you have there as kind of a shortcut. I like to explain where it's coming from, and the formula shows where it's coming from. The shortcuts are always good for memorization. Use either one. I'm happy. I would be okay with either one. Any questions? You're welcome. Any questions you might have? No? Okay. When there is no question, no concern, that means that I have to call attendance and I let you go to watch the video, start being worried about the lab report. But if you have questions, mass, the observed rotation, it depends on the mass. Okay, observed rotation depends on the mass. So when you get your observed rotation, the alpha, then you have to divide that by concentration. And the concentration, it comes from mass divided by C. Okay, the value for C is concentration in gram per milliliter, is a weight volume concentration. That's this unique unit is used for the polarimeter. So the value for C. And in order to find the value for C, you have to have the weight of your enantiomer. So you find the mass of the enantiomer first, then you use this formula. And I hope I answered your question. Yes, definitely. Use that equation to get the specific rotation. Great. Okay, Tarek, this is for attendance. Data. Rosie, I think Rosie is not in this class. Ashana. Elizabeth. Jennifer. Okay. Just in case you send an email, I try to reply to emails. The only thing that I have only weakness that my emails are not very long. Some of you like short answers, some of you may not like short answers, but that's the only problem I have. I do reply with like short and precise answers, but I do reply. In case if I didn't reply or I didn't answer your question, you can use this time of the class, stay after and tell me what your concern or question was, and I try to answer it right here. Alexis, because I just remembered Jennifer sent me an email. I just don't know if it was Jennifer from this class or a different class. Just want to make sure that I answer the question. Caleb. Caleb, not here. Okay. Every other class. Valentina. Danielle. Mariah. Catania. Catania. I had to log in a couple of times. Okay. Ashana. I already called your name. Sorry. Anifal. Anifal's absent. Anam. Thank you. Sammy. Cassandra. Craig. Thank you. Antonia. Okay. No, I'm sorry. I'm glad you told me. Okay, perfect. Did I call everybody's name? Yes? Thank you. And have a nice day. Have a great day. If you have any questions, you may stay. If you don't have questions, you can start watching the video. You have one lab report and one PDF images for the both part 1 and 2 of the experiment 7. Have a nice day. Thank you. Let me know if I didn't answer any questions that you have asked in the past.